Okay, so this video is to explain how ionic bonds form. So ionic bonds exist between a metal, for example sodium, and metals are all found on the left of the periodic table, and a non-metal. Non-metals are found on the right of the periodic table. So ionic bonds always occur between them. Now ionic bonds form when ions, which are charged particles which have gained or lost their electrons, are bonded together by the electrostatic interaction between them, which is a type of attractive force. So sodium, if you look on a periodic table, sodium has 11 electrons, so 2 go into the first shell, and then 8 go into the second shell, and then there is 1 remaining electron on the outer shell. Now it's easier for sodium to lose that electron than it is for it to gain 7 others. Now you might think, why might it lose it, or why might it gain it? The reason for that is because atoms are most stable when they have a full outer shell. So sodium has one shell that has only 1 electron in it, so it wants to lose that electron so that it's left with a full outer shell. Chlorine, on the other hand, has 17 electrons. That means that it has 2, 8, 7. So it has 1 space in its outer shell. So for chlorine, it's more likely for it to want to gain that 1 electron than to lose it. So what happens is this electron from the sodium will be lost and come over to the chlorine. So when we draw this out, we draw the atoms first. Then, once we've done that, we draw the ions again, and we only draw the shells that are full. So for sodium, I only draw those 2 shells. I draw the electrons that are still there, the 10 of them. The outer electron's been lost, and that has travelled over to the chlorine, so we draw the same shells again, but for chlorine it's got all 3 still. And it's important to note that I'm representing crosses as electrons for one element, and dots as electrons for the other element. So the reason we do that is so that once this diagram is finished, you can see where the electrons come from. So from here, this 1 electron from the sodium is going to come over to this point on the chlorine, which we represent like that. And to finish, we put each of the now ions in square brackets, and we write the charge on them. So sodium will form a +1 charge because it's lost 1 electron and therefore has 1 less negative, and chlorine has gained an electron, so it will be -1. For lithium fluoride, as another example, lithium has 3 electrons in its outer shell, so it will lose that outer electron, exactly the same as sodium. So that is a lithium atom. And fluorine has 9 electrons, so 2 in its inner shell and then 7 in its outer shell. So those are the atoms, so we draw those first. And again, notice I'm using dots and crosses. And fluorine has 1 space, lithium has 1 extra electron. So what they're going to do, lithium is going to lose that outer electron, so it's going to be left with just its inner shell. Because it's lost that 1 electron, it's lost a negative charge, so overall it has a charge of +1. And fluorine, that has now gained an electron, so if it's gained an electron, it's going to have an extra negative charge. And remember to show the electron that it's gained as a cross. It does not matter whether you use dots or crosses for the metal or the non-metal, as long as you're consistent. So we put that electron there, so that's travelled from the lithium to the fluorine. Use our square brackets again, and then we put -1.